The 8000 series story began in 2007, although we'd been building forage harvesters for more than 40 years. It was to be the most tested product we have ever built. This is the story of how we did it. It all began with our customers telling us what was good about our current machines and what we needed to improve. From the start, the team were tasked to question everything. The first designs were made at the click of a mouse. Finite element analysis used real field data to help identify potential stresses in new components. Here, the stress on a feed roll bearing is being tested. These early designs were used in combination with what we call a mule. A hybrid of a 7000 series Forager was equipped with over 1000 horsepower, so we could field test every new component to maximum power. At the same time, we carried out lab testing on individual components, from axles to wiring systems. Experimenting with different loads, different systems, testing, and more testing. In early 2009, we were ready to build our first machines. By that time, we'd replaced 90% of the 7000 series, over 5,000 new components. These first machines were heavily disguised, with a profile big enough to test different power configurations and engine layouts. Field data was gathered in lots of different conditions. In the middle of winter, when field testing stopped, we headed for Malign in the US and used the field data at our accelerated design and verification test facility. Test engineer Ryan Blodick picks up the story.
This particular machine was taken to the field with about 150 channels of instrumentation on it. Operations were collected to replicate what an aggressive type customer would do with the machine. And then we've used that field data we collected to develop a lab test here. We're monitoring loads at the wheels, loads coming in from the header into the chassis, accelerations at different locations on the chassis, and also strain gauges on the chassis as well. So this test will simulate an equivalent of 4,500 field hours, but it will do it in about 700 lab hours. So we can accumulate the full life of a machine in roughly 40 days here in the lab. We run around the clock, 24 hours a day, 7 days a week. In the end, that's the whole goal of this testing, is to find all these failure modes here in the lab so they can be addressed with design changes long before we get to production, so that our customers buy a robust machine that has minimal chance for any failures.
When one set of tests had finished, the machine was reset. Bet you've never seen a Forager fly.
So we're looking for the structural integrity of all the structures on the machine. So we look for broken parts, cracked welds, buckled parts, loose bolts, broken bolts. Yeah, we've had one significant failure. This particular bolt right here retains the cutter head pivot casting. So it's the main retention bolt for the cutter head on one side of the machine, and it failed. We've also since learned that they've had the same failure in the field. So it's good correlation that we're actually replicating and reproducing known field issues too.
So now that information will go back to our engineering group in Zweibrücken, and they can work on relieving the stress or adding strength to that actual bolt.
Correct, yeah, they're actually working on a design change to address this issue right now. Once we have the design change, the new parts made, we will install those onto this machine and continue testing with those new parts to verify that they have indeed fixed the issue.
We soon fixed the part, and our next stop was the UK, where thick, heavy grass gave us a new set of challenges.